Hey guys, it's Jesse from freehaltwater.au and gridless.com.au. In this video, I interview Mike Siddons. It's a very good video. I'm very excited for it. Mike Siddons is the inventor of all-in-one heat pumps. He invented the first heat pump ever. So a bit of history for you. Heat pumps initially, they were a collaboration between Siddons Ramset and the University of Melbourne. You had the heat pump, but it was also connected to a panel on the roof, so it was sort of like a solar heat pump system. And Mike was the guy who came up with the idea of not even having the solar system to reduce costs and just having the tank and the compressor together. So Mike effectively invented heat pump hot water systems as we know it today. He designed Quantum's systems, the all-in-one system and their split system, which have barely changed over the past 30 years. And in fact, some of them still last up to 30 years. So very good longevity on some of his products. After Quantum, he invented Siddon Solar Stream, and then after that, Ecoalliance actually recruited him to invent their latest set of products, the Ecogenica, with the flagship Ecogenica 290, which has been rated as Australia's #1 heat pump. It's an interesting situation because it is the most efficient heat pump hot water system in the world, but it's actually offered at a very, very good price, so the value for money is there. A lot of people get stuck in the idea of value equals price spent, and we sort of distill that and we find out why that's not necessarily the case and how Ecogenica is able to provide such a good performing system at such good value. Ecogenica is designed in Australia right here by Mike and made in China. So we go into the details of the system, and then we go into so the layout of this video is we talk about the system, and then after we talk about the system, we actually just interview him and ask him about some specific questions about the history of heat pumps and the Ecogenica itself. So I found this to be a really insightful, interesting video. Let us know if you have any questions. Mike would be happy to answer them.
Okay, so we've just turned on the Ecogenica. The water temperature is at 21.9. Yep. And it's now 11:49. And what we're going to do is let the system run for a while, and then we'll go over here and just see how long it takes to get some hot water coming out of the shower. So we've got a little shower set up here, and then if we turn this on, you can see that that's cold. You can put your hand under there.
Yep.
That's nice.
Can confirm.
That's cold. So we'll just let that run, and then we can go and talk a bit about the systems. And here, I've quieted this bottle. Maybe I'll just explain to you a bit. So this is your evaporator. So it's a single row evaporator, which means that it's got a large surface area, absorbs a lot of energy from the atmosphere, unlike a 3-row, which you'll see in all-in-one. The condenser is this unit here. So the condenser on the Ecogenica is from the very bottom to around about the midsection. So it means that there's a jacket wrapped around the tank, and that heats the water inside. The cold water comes in, and gradually the heat will raise, increase, and build up into this section. Now this particular model is the commercial model, so it comes with a 3.6 kilowatt element at the top. And that element is designed just to heat the water at the top of the tank a little bit. So as the heat pump is heating the water in the tank, it means that if this needs to raise a couple of degrees, the element will kick in and do that. So that's really for extreme situations in a commercial environment, and these commercial units are designed to provide a huge amount of hot water. So they're meant to be generating hot water, but they are also the most energy efficient heat pump on the market today.
Do you have any idea how many litres a day the commercial unit could heat up?
You can run this thing for half a day. It doesn't run out of hot water.
Wow.
But yeah, it can do about 2,000 litres. So that's just on the heat pump alone.
It's a lot of hot water.
Yeah,
That's without using the element
Yeah.
as an extra.
Yeah.
Right.
So it's going to do around 80 to 90 litres of hot water per hour.
Okay.
Right? So the beauty of it is that it was developed by myself using this direct heat transfer technology. And what that means is that you don't use a heat exchanger or a heat pump. So our old original units were what they called the Ecoalliance Dyna heat. And I joined the business about 2.5 years ago. The first thing I was asked to do was to completely redevelop the business. So just behind you, Jesse, you see one of the Dyna heats. And in the old design, it used to have a compressor in here, a heat exchanger, and a little circulation pump. And this technology is still used in Australia, actually by some of the more expensive brands, strangely enough. And the way it works is that the compressor heats the refrigerant, it runs through a heat exchanger, and water is pumped through that heat exchanger and back into the tank. So you have this circulation of water into the tank. So you get two weak spots there. You've got firstly the issue with the circulation pump, and then secondly, heat exchangers are notorious for getting mineral deposit build up on them, which creates a inefficiency in that heat exchange, and that reduces performance and will result in early compressor failure if it's not maintained properly. So we moved away from this technology.
The pump can fail as well, right?
Yeah. Well, all of those things come together, and it's a weak spot. So the beauty of the Ecogenica technology is there's no moving parts, very few in the whole design, but there's no moving parts in the heat transfer. So you've got the hot refrigerant gas comes out of here, travels into here, goes around the jacket heats the water, and then as the heat comes out of the refrigerant, it passes back into here, goes through an expansion valve, and then becomes cold, passes through the evaporator, picks up energy, comes back into the compressor, where it becomes superheated, and then the cycle continues. So you're constantly going from high pressure to low pressure, and the system will just naturally absorb energy and release energy into the tank. So that's the beauty of the design. So the design principle was from the get-go to be more reliable, simpler. It's designed to be not an expensive unit to manufacture, but it was designed to have the optimum in energy efficiency. So I've designed it where the tank is optimized and the fin coil is optimized for the capture and release of energy. So we've had very, very few issues with this design, and we see this as something of a classic design that will hopefully be in the market for well over 20 years. So I've got products in the market that is up to 30 years old. So my original products were the quantum energy systems, which I designed, or their all-in-one systems and their split systems, and then the Siddon solar streams, and now the Ecogenica. And we have new models coming out as well, which will be something of a radical change from existing technology as well. So we're constantly designing and developing. So this warehouse is where I live. That's where I do my design work. So I'll show you around. In the background, that's the new commercial model, which is a 12 kilowatt heat pump. This one is a 3.6 kilowatt heat pump, and the one we're going to look at just now is a 4.6 kilowatt heat pump. So we've got 3.6, 4.6, 12. So they're fairly powerful units compared to other units on the market. So let's go and have a look. So these ones here are the all-in-ones, and they're one of the most powerful all-in-ones on the market currently. This is the new 330, so it's a 330 litre tank. It has a 4.8 kilowatt element and a 4.6 kilowatt heat pump. So the way the system works is this is the flexible condenser pipe, and that comes down, and then you connect it in here with a quick connect system. It's unique to Ecogenica. And the quick connect system means that there's no requirement for charging or handling of the refrigerant, which is propane, so it's actually a natural gas. Very good thing, and then it's not a dangerous gas in the environment, it's a natural gas, it's natural in the environment. It's the same gas that's used in natural gas actually, and used in LPG propane.
Okay.
So that connects up to here, and basically then it's just this particular model has to be hardwired, the other one doesn't. And we've got the heat pump, so over there.
Alright, we'll just pause it for a sec.
This model has to be hardwired. This is the commercial model.
Yep.
So the 290, the one we see over here, doesn't have an element. So this is the classic 290 for residential.
Yep. Do you want to talk about that?
Yeah. So this is the 290 residential model. So this is just a heat pump, putting into the water up to 4 kilowatts of power. In fact, when the water's cold, we will put into the water up to 8 kilowatts of power. So you get a very fast recovery. A good thing about this is that it doesn't use more than 5 amps, so it's a very small power consumption. Yet it's because it's absorbing a lot of energy from the atmosphere, it puts a lot of energy into the water. Because you've got this big fin coil, which you see up there, you can extract a lot of energy in a single row. And, see how large the fin coil is, so it's in a way it's almost oversized for the size of the compressor.
Yep. What makes this system, so this was rated the #1 most efficient system in Australia.
Yeah.
Why?
Okay, well I can't give away all the trade secrets here, Jesse, but so basically it's an oversized evaporator and the optimized condenser tank. So it uses a micro channel condenser jacket which wraps around the tank, and then we've optimized that. We've made some improvements to that technology, so it actually uses some other technologies in there as well. But basically it heats the water from the bottom up, and so what that means is that when the heater turns off temperature, you've got just about a full tank of hot water, as where some other technologies out there, they might heat from the top down, so you get a lot of stratification. It means that you have a lot of cold water at the bottom. And so when you go to have a shower, you might not get the full amount of that hot water, but with the Ecogenica you will. It's got a lot of energy in the tank, a lot of hot water in the tank.
And you were mentioning that's even some of the more expensive brands that are going $4,000, $5,000 in price.
Yeah, it's ironic, isn't it?
Yep.
Yeah. So more hot water, lower cost to run, and a more reliable system. And as I said, this technology is the evolution of designs that I've been working on for the last 30 years. And even my early designs are still in operation in many applications. So they've stood the test of time. And it's interesting to say too that the designs that I've worked on haven't been responsible for large-scale warranties and breakdowns like some other large companies in Australia that have heat pumps come out and then have all those products come back under warranty, upsetting customers and giving some of the schemes a bad reputation, which happened 10, 20 years ago. Some people still recall that when a lot of heat pumps started breaking down. But my products, they didn't break down.
There's still some quantum units
as a caveat
for 30 years.
So I used to run quantum from 95 to 99, and we used to sell those products around the world. We did large-scale hotels, Raffles, Crown Plaza, La Meridian, Sheratons. We did Army, Navy bases here in Australia. We did a lot of projects, but we did that without rebates. Okay. Now, quantum did get into some trouble. I had nothing to do with the business at that time, and there were some changes to the technology in terms of the compressor and the type of refrigerants, and just small sort of tweaks here and there. But sometimes it doesn't take much to get a system that's unbalanced. So one of the things we do here is we make sure the system is really well balanced, and it's a bit like a car. You know, if the car's not properly tuned, you're going to have problems. And it's the same thing with a heat pump, and it does take a lot of experience. And our team are very experienced and very sort of practical. We haven't come in from some, like some crazy university and studied physics and then, start playing with heat pumps. No, we've actually come, most of the people here are really experienced with heat pumps. Okay, so this is the 260. The 260 is designed to be a slimline tank.
Yep.
For residential commercial applications, and so it means that the tank can go into a narrow space. Like if you think about the space between the house and your neighbours, it might be restricted space. So instead of being a 660 diameter tank, it's a 600 diameter. It doesn't make the tank taller, but it makes it thinner. So that's really the advantage of it. It's one of the most efficient units in its market space, which is the all-in-one space. And it is a very, very well high-performing system. You get so much hot water out of one of these things, it's incredible. We've tried, running the unit, filling up baths, and it just keeps going. So it's a real workhorse. It's not the most pretty unit on the market, but if someone wants something that's a slimmer tank design, makes a lot of hot water, and is super efficient and very quiet, then this is a great model. This is a 3-row versus a single row. So all-in-ones are typically 3-row fin coils. So it's a shorter, fatter coil, but it's also less efficient than a split. Okay, and the reason is that the air comes across here. As it passes the thin coil at this point, it loses temperature. It might lose 2 degrees. So air comes in at 30. It then comes into this one at 28, and then this one at 26.
Right.
And so the higher the temperature, the more efficient is the system. So just by its very nature. And the problem is that when it gets really cold, the same thing happens, but as you're driving down to like 6 degrees ambient, 4 degrees ambient, you'll start to get issues with frosting on all these systems. So this has a very sophisticated de-icing circuit. It'll go into a reverse cycle and keep that coil free of ice at all times. So that's how we get the high efficiencies in the design. Comes with a sound reducing jacket and the controller, and which we're playing with. It's an R&D project here. So this is not how they normally are. So there you go. So this one here, this is a commercial type installation where you might have 2 tanks and an equal flow manifold, and we've been doing some testing on this and some testing on this. So this is kind of where we do our testing, and over there, and this is my office. So this is where I do all my designs in here. And Alfred, hey Alfred, go. He's using my office. And so it's a pretty relaxed kind of place, Yeah. And it's Anna. She's one of our technical assistants.
I am.
You are. Yeah, you are. Yeah. It's not. So the idea of this one is 12 to 14 kilowatt heat pump. So if you've got a hotel, you need 140 kilowatts. You put in, or you need 120 kilowatts or 100 kilowatts of heating power. Yeah, you put in 10 or so of those on your roof. You get the forklift, comes in, puts it on the lifts, takes it up to the top, puts it in place. It's all good to go. Plumbing's pre-charged, pre-designed. The refrigeration is all there. It doesn't need anything but cold water inlet, hot water outlet. 400 litres, you put in 10, you've got 4,000 litres of storage. You've got 140 kilowatts of power. That system's going to cost you about 250 grand if you go through normal engineered solutions, or you can get it from us for a fraction of that price. Now, that is just a heat pump, there's no elements in it. So we'd normally recommend a large water storage tank as well. So you might want to put in another 400 or something like that with some elements for the ring mate, for the reticulation. So that's typically, that we'll help you with that design if if people want to do that. So if you think about a commercial building at the top, you normally got those HVAC units. This one blows out from the top. It's a single row fin coil, so it's extremely efficient and very robust. It's like a tank. We can pull this one apart, so it normally is screwed together. 3-phase, so it's all hardwired in. You've got your connection which needs to go into your power there. And these panels come apart, so it's very easy to service and access the tank and the various components within the tank.
These systems are super efficient, aren't they?
Oh yeah.
These ones.
Yeah. So that's a COP of 4.6.
Yep.
The 330 is 4.6.
Yep.
And these ones, the 290, they're over 5.
Yep.
So basically, that is the most efficient. The next efficient units are your CO2 units. They're coming in around about 5. So this is actually a little bit more. We sacrifice a little bit of efficiency for this one and the 330 because we're putting in a lot more power. Okay. So if we come back here now, we'll just have a look at this. So this is now running at 37 here. The 30.7 I meant to say. That's what I'm saying. And
do you want to show us the time on your phone?
yeah, sure. So we've been running that 12:10. I can't remember what time we started. It was 11 something.
Yeah, I think 20 minutes.
20 minutes.
Yeah.
So it's already at 31. So if we go across to the tap, this won't be hot, but you would be able to feel
Be warm.
in that shower. Just wait for the hot water to come through. So there you go there now.
Yep. Warm.
You can, yeah, it's warm. You can shower in that
Yep.
easily. That'd be a nice warm shower. But we'll leave it a bit longer, and that'll be up to around 40. So that is tempered to 42 degrees. And my experience is when we run these units that you get to that temperature within about half an hour or 40 minutes at the most. Okay. Now that's the commercial one, of course. All right, so should we just go inside? You can just ask me questions, yeah?
Let's do it.
Done.
And how is it able to outperform these really premium systems that can cost $4,000, $5,000, even into $6,000? This system outperforms them. And I guess my follow-up as well is a lot of these systems, a lot of people online are saying, well, it might be cheap, it might be high performing, but how long is the system really going to last? We get a lot of, it's Chinese made crap, it's only going to last like 5 years. What would your response to that be?
Okay. All right. Well, there's I think 3 or 4 questions in there. What the first thing I'll explain is this company is an Australian company. It's designed here in Australia and then manufactured in our joint venture partner operation overseas in China. So the supply chain in our instance is very narrow. Our overheads are very low, and the business has been structured around supplying to this rebate scheme the most energy efficient and best value products. So we go direct to market, and we use people like yourselves who are young and innovative, have innovative ways of doing business, but don't have a huge amount of overheads. You're not some big, fancy company with some fancy advertising agency and fancy plumbing trade, distribution networks. You're Jamie. Jesse.
I'll edit that out.
You're Jesse.
Yes.
And so that's the secret to it, is that we have a very sort of vertically integrated, flat horizontal structure that provides low cost and optimum benefit to the customer. Now, in terms of the design and the longevity of the design, I started. I was telling you before. I basically did my apprenticeship out at Siddon, designing heat pumps with the guys from Melbourne University and the engineers at Siddon. I had a little office out there, and we did a lot of R&D. And then eventually, that business, which was Siddons Energy Systems, became Quantum, and I ended up running that business and doing all those designs. And I developed the first all-in-one product, which I've been very proud of, because those products are still, they're still around. They're still in circulation 30 years ago, and they haven't really changed. The all-in-ones that we make today, the Quantum make, that iStore and other products make, they're effectively the same, concept. What has changed is we now use a heat jacket, as where before we had a coil wrapped around the tank, and we use a much more advanced, it's a microchannel design heat jacket, which we've developed and advanced over the years.
Do you want to explain the difference between a micro jacket?
Yeah, so the microchannel is basically a flat piece of aluminium with kind of really small perforations from the holes in it, rather, and so the refrigerant goes through that jacket, or these bands of aluminium which are wrapped around the tank. And what actually happens is that the tank becomes a heat exchanger, and it's a bit like if you think about one of those steel vitreous enamel fry pans, like the French ones and so on, that you put on a hot plate. The hot plate heats the fry pan, and then the fry pan will boil the water. It's the same technology, so the heat is applied to the outside skin of the steel cylinder. The cylinder heats up, heating the water inside. So it's a very direct heat transfer. We're not using circulation pumps or heat exchangers or coils in water, any of that rubbish. It's, a solid steel heat exchanger, which is the tank heating the water. And so we started doing that over 30 years ago, and the original Siddons was called the Siddons Solar Plus, and then it became the Quantum, and then I developed another set of products, which was the Siddons Solar Stream, and then it became the Ecogenica. So all using this technology. So it's technology that's been proven to last over 30 years. In fact, I was talking to one of my cousins just recently at a family get-together, and I sold him his Quantum in 1994, and he still got it.
Wow.
In fact, he still got it. Yeah. He was complaining that people keep ringing him up for him to change it over under the rebate scheme. And I was like, Philip, trust me, if you ever want to change it, don't call me.
That's an incredible amount of time. So people say,
yeah.
I think even most heat pumps that are built today, they probably wouldn't last 30 years.
Yeah, possibly. Our systems are lasting, the Ecogenica ones are lasting a very long time. And I have every expectation that they'll last 20 years.
Okay.
I don't see any reason why they won't. See, the benefit of a heat exchange, a condenser tank system, is that the heat's applied evenly and gently over the whole skin of the tank. Okay, so you don't get any heat spots, don't get any localized heating, any of that kind of thing that affects electric water heaters. And because it expands and contracts slowly, means that you don't get any finite cracks in the vitreous enamel glass lining, which is on the inside of the cylinder.
Okay.
And so it's a very simple system because...
And that's not the case with a lot of other designs in the market. Even the more premium brands, they don't have that heating design.
No, they would use a circulation system.
Yeah.
Which is what Ecoalliance used to use.
Yeah.
So
before you came on board?
Yeah, before I came on board. So when I came on board, my role was really to transition from that kind of design to the direct heat transfer, which is what we've done. But where our product is a little bit different to some of the competitors is we use, but look, I won't go into it in too much detail, with IP issues and so on, but basically what we try and do is really have optimum size evaporator and condenser. The evaporator is the cold side of the refrigeration circuit that's absorbing heat from the air, and the condenser is the tank and that is putting heat into the water. So they're optimized and balanced. It's like a car. You need to, if the car is not balanced properly, if it's not in tune, that car will start to fail. So from the get-go, the design is to be, really well balanced, so it doesn't operate under stress. And we've shown that in our own testing, that the compressors run very, very comfortably. So they will last a long time. We're also using natural refrigerants, R290, which is propane, which is basically the same gas that you use in a barbecue. And that gas has the ability to absorb heat from the air really well, down to very cold temperatures. So it is actually a kind of perfect gas, strangely enough. And it's sort of an interesting thing that it's taken this long for the industry to embrace it, as where for many years we were using, manufactured refrigerants, which were bad for the ozone. Yeah. And now people have all of a sudden found natural refrigerants, and the two popular ones are CO2 and propane.
How do you think CO2 and propane compare?
Now CO2 is a very good system. That is, CO2 heat pumps are very good systems. It's good gas, and it operates at extremely high pressures. So only a few manufacturers globally are able to make those systems. Because
CO2 or propane?
CO2. Yeah, because it's operating at such high pressures, you're putting a lot of stress on the compressors and the refrigeration circuit and so on. But it can operate to very high temperature because it's at that high pressure. And it does operate, very efficiently. So, CO2 systems do operate at a premium in Australia. But you do need to sort of wonder about that in a way. It's at the end of the day, the propane is probably better performing and maybe better for the Australian environment, given that we don't have a lot of sub-zero temperatures in this country, which is where the CO2 seems to come into its own. It's in the zone of 0 to -20.
Okay.
So it's developed for China and actually I'm going to say Japan just then, sorry, where you get those really cold winters. You get them in China as well, of course, but you get that Arctic weather coming through, which you don't get in Australia.
Not so much good, yeah.
Not really, no, not sort of like -20.
So R290 performs better in these warmer environments. Why is that?
It's just the properties of the gas,
Yeah.
The boiling points of the refrigerant, that kind of thing.
Okay.
But R290 actually performs in cold weather very well. So in Europe, it's starting to be used for heating systems now, and they're getting fantastic results. But it is a much easier gas to handle than CO2. So, but look, they're both great systems, and don't get me wrong on that. But they're a big improvement from the old refrigeration systems.
Yeah, it's interesting that it's just natural gas that's being used instead of these manufactured. It seems way easier as well.
Better for the environment, easier. Yeah,
There
are some handling issues and some other kind of engineering considerations that were taken into account.
Yeah.
But
it'd be extremely cheap as well if you ran out of there was some leakage of refrigerant if you needed to put that in.
No, not really. Kind of. But look, R290, it's refrigerant grade propane, so it's not.
That's different than just regular propane you get. From
it's got oil actually in it, a little bit of oil.
Okay.
To be honest.
Don't drink it.
No, you can't drink propane, mate. So in its natural form, it's extremely cold.
Yeah.
Right? So when it's exposed to air, it absorbs heat. That's how it works. And then when you absorb heat, it's very similar to if you get a bicycle pump in your finger and then press it, you burn your finger. So that's how a compressor works.
Yes.
You're just compressing the gas,
Cool. So do you want to, you sort of touched on it briefly, but do you want to tell us about your experience actually inventing heat pumps, all-in-one systems at Quantum?
Yeah. It's interesting, Jesse. It's funny, looking at yourself and talking to you. You remind me of me about 30 years ago, So don't get worried. You might not lose your hair, put on all this weight. But yeah, I was a young guy. Yeah, I was. It was funny. My first 10 to 20 years of working, everyone I worked with was kind of in their 50s, and I was in my 20s. So I developed all the quantum product. I was still basically in my 20s.
I saw the photos. I'll put it up.
Yeah.
How old were you in that photo? Were you just?
I was about 28.
Okay.
Yeah. But I'd started installing and managing the sales for Siddons energy systems out of a little office next to the boardroom at Siddon, and I was basically mentored by Bill Charters, Professor of Engineering at Melbourne Uni, and some other people, and I had a lot of hands-on experience working with all those engineers back then, and then I started installing them and selling them. And then it became very clear to me what all the problems were with the product, because I was so sort of hands-on. And back then it was a solar boosted heat pump, and we might try and get you a photo of one so you can see what they look like. And they basically had this aluminium panel on the roof. It was a technology that was developed by Melbourne Uni. And Siddons Ramset, they came up with the idea of the coil wrapped around the tank. So they did that part of it, and Melbourne Uni did the solar boosted part. And I then decided to just basically get rid of that solar boosted bit. So all that work that Melbourne University did over like 15 years, I just decided to get rid of it.
Yeah.
And I thought what we needed was, just using off-the-shelf products to bring the price down, make it more convenient.
No complicated roof installations.
Yeah, and that's been my philosophy, and it's basically the philosophy of Ecogenica and this whole business. So it's all about, it's just about doing things simply, effectively, professionally, but taking costs out of. So by moving to an off-the-shelf evaporator in the quantum design, I managed to reduce a lot of costs, and then I came up with the idea of putting it on the tank. And it's sort of funny, because I'm working on some new designs now, which are quite revolutionary as well. But it's really, I think it takes, it's funny when you're working on something that's never been designed before. And people kind of look at you and they go, what is it? Like, why are you doing that? They can't sort of understand it, and it's sort of like, sometimes you go home and you think, God, is this just going to be a complete waste of time, But we developed it, and then we put it out into the field here in New South Wales first. And we were a little concerned about its performance in Victoria. And over the years, that actually was true. It's taken, I'd say, about 10 to 15 years to get the de-icing on the all-in-ones really down hat. But the design was really good. It was a sort of a, pick it up, put it in, plug it in, bang, off you go, and that was the concept of the all-in-one, and those products really haven't changed much since. So it's good to get it right first. The Ecogenica product is a evolution of another product called the Siddon Solar Stream, and that was another product I developed actually in the 2000s when I set up the business with my brothers, and we developed this business around an idea that I've been exploring actually in quantum, and it was for a quick connect. So basically the idea was that you didn't need to use a refrigeration mechanic to charge and evacuate the unit. You just took it to site, click, and basically it's good to go. So it has these couplings. They were Parker couplings back then. It's got a female and a male section. The female has a copper manifold, and when you screw the two pieces together, the male section pierces the female manifold, pushing it back, creating a one-shot seal. And I think it's a little bit, yes, I know. But that's how it works. And the high pressure gas then comes into the low pressure side, and bang, the system's alive.
Yeah, cool.
Yeah.
I'll just make sure we're still recording, so we're not losing any good content, and we're not just talking.
Yeah.
My question is, I mean, you've talked about the economies of scale and the simple way that Ecogenica does things that make it a pretty affordable system.
Yeah.
How is it that some companies are charging such a premium? Like, how are they able to do that?
Well, you need to ask those companies.
Okay, I'll get on the, I'll give them a call.
Yeah.
See if they pick up.
Yeah, it's just us then. But, I mean,
I'm
from
sure.
our point of view, we run a very lean ship, and the idea from the get-go is to make a product that is extremely affordable and efficient. And actually, one thing that I need to say, and people don't understand this, is that our designs get a huge amount of government subsidies because they're so efficient. The efficiency drives the subsidy.
Yeah.
Right?
They were ranked as the #1 performing system, the 290 in all of Australia.
Yeah, and so it gets a very large subsidy. So products that aren't as efficient as the Ecogenica product don't get as much in the way of government subsidies, and they often come through different supply channels. So most of the products in the Australian market are manufactured by a couple of companies in China.
Yeah.
Our company and our factory is separate to that. We only make product for ourselves.
It's true, there's a lot of products which are actually the same product that come out of the same, they're just different skins.
Yeah, exactly. You've got big organisations like Medea and other companies that make different sort of heat pumps and different brands, and they're represented here in Australia under different brands. But they're the same company. But because you've got a manufacturer, and then you've got an Australian company, and then you've got all your distribution channels, prices can be high.
Cool. Do you think heat pumps are the best way to heat up hot water?
Yeah. I think it is. So there are some limitations in heat pump technology. So people need to understand when they're putting in a heat pump that heat pump is an environmental system. Its performance will diminish in colder weather. Its performance will still be substantially better than an electric or gas system in terms of its efficiency, but the recovery rates will become longer. And my advice to anybody who's looking to invest in a heat pump water heater is look at the performance, look at the capacity of that system. And to look at the capacity of that system. So if you're looking to purchase a 2.4 kilowatt heat pump, you need to realise that in winter, that 2.4 kilowatt heat pump is not 2.4, it might be 2 or even 1.5.
And that's the output
kilowatts.
that you're talking about.
Yeah, the heat output, that's right. So you really want to try and get something that is around 3.6 kilowatts in terms of output.
Yeah, similar to a standard electric.
Correct.
Yeah.
That's right.
Cool. Is there anything else that we sort of left off that you would want to mention?
Let me think. So you want to be, installation is a big issue, and there's been a lot of discussions about how heat pumps are installed, and a lot of those discussions are important. There's been a lot of work done by numerous companies and consultants to ensure that heat pumps get installed correctly, with the lagging done properly. And the lagging should be on the heat pump inlets and outlets and on your pressure relief valve.
Yeah.
But you also need to make sure that you're lagging on the hose. Well, the biggest difference, so to be on the inlet and the pressure relief valve, it actually makes no difference under most environmental conditions. But if it gets extremely cold, you can have freezing in the pipe if it's not lagged. So then it makes a massive difference because you can't release the water and the pressure relief. In terms of energy costs, on the heat outlet, if it's not lagged, well, you're just heating the air. You know, the hot water is going through those pipes, heats the copper, and then the copper's heating the air. So you need that lagged, and the home needs lagging. It's surprising in Australia, you know, you go underneath the house and you look at the pipes, hot water pipes, and often they're completely exposed to the air, or they have that old-fashioned green, really thin, like it's about 3 mil lagging on them. And sometimes people are sitting there going, "Oh, I've got no hot water," and it's like
It's just being used up on the way.
yeah. It's like, you're just going to have to wait 5 minutes because guess what? Your house isn't lagged properly.
Yeah.
So it is worth getting those pipes properly lagged if you can.
Awesome. Anything else that we missed?
The location of heat pumps probably needs to be discussed. Do you think?
The location?
Yeah.
Where? Yeah. Okay.
Yeah. So you just need to be mindful where you're installing them. With a heat pump, you need to make sure that there's clean air available to the heat pump. So if it's not, it will reduce the temperature in the location that it's installed. So the unit that sits outside, which is your evaporator and your compressor unit, that's basically it's air conditioning that space. So if there isn't good airflow, it will drop the temperature and the performance will diminish.
Yeah. So no dusty basements.
Yeah, that's right. So there are designs that can go in basements, but you need to speak to a consultant to make sure you get the right product for that.
Cool. Anything else?
Well, there's a lot, but I think they're the main issues.
I think that's good. If we have any questions afterwards, I'm sure we could do another session.
Yeah.
Obviously, write any comments that you have, and Mike would be happy to answer them in another video. So any questions, technical details you have about heat pumps that you're not able to get anywhere else because no one is really answering your questions honestly, just type in the comments and we will put out another video.
Okay.
Right, we're going to check on the heat pump temperature.
Oh, you.
This is the CEO of Ecogenica.
Yeah. You can say hello to Alfred too.
How'd you go?
Good, we're still going. Do you
Get
guys,
you on camera.
you want to be on camera?
This is Alfred, our operations manager.
One sec.
Gotta brush your hair.
Yeah.
Look good.
I wish I
slick.
knew that.
And Anna, head of HR.
I know.
Howdy doody. We're happy here. We're all happy.
We're all happy.
Well, yeah. Good. You need to use the room. Just use the room.
Yeah, you can use it, man.
Okay.
Go for it. We're just going to look at the heat pumps.
Please do.
Yeah.
See ya. Okay, so first I'll get you do, Jesse, is
Burn
chuck
my
your
hand.
hand under there.
Got my hand.
No, it's tempered, it won't be burning. So, but that should be,
It's quite hot.
yeah, oh yeah, that's right. So I've got that up full ball, you can see the tap here.
Yep.
So I can bring that temperature back, but it is tempered, so it won't be more.
That was too hot to massage actually.
Yeah, so that's now at a good temperature. And we can see what temperature it's at. So at the halfway point, we're now sitting at 43. But in actual fact, if we take this from the top, the water's going everywhere, and we'll just
Do you want me to...
pick up that sensor here. So that's 56 degrees at the top of the tank.
At the top of the tank, 56.
Alright. So 44 at the midpoint and 57 now at the top. Right, I'll just turn that off. That's coming from the PNT. And we are now at let's do a temperature time is 12:50. Okay.
All right. Well done.
Done.
Hey guys, thank you so much for watching the video. I hope you found it very informative. If you're looking to get a heat pump hot water system, please just visit freehotwater.au and put in your details, and one of our experts will call you to discuss a system that will be suitable for your needs. Thank you so much for watching. If you have any questions or any future videos you would like me to make, please just make a comment, or you can even send me an email at information@freehotwater.au.